Hello everybody. Today we're going to be dividing rational expressions, and it's just one example. One thing that you need to know about dividing rational expressions is it can come in a lot of different shapes and forms. So we're just going to try this one out, and we're going to see all the different factoring techniques that are involved. So we are dividing, and we're going to treat this just like fractions. When you divide, we're going to keep our first term, we're going to change this to multiplication, and then we're going to do the reciprocal. We always want to do that at the beginning to go ahead and take care of our sign. All right, so that is what we have. Then you take a step back and you just look at what are all the different factoring techniques available. So if you see this first one, this is called greatest common factor, since they both have a 4 that they're divisible by. So I'm just going to take a 4 out. 4 times what gives me 4y? So y, and 4 times what gives me 3. And below, you should be excited because it's a really similar form. You're going to do the same thing. What number are they divisible by? It's going to be 2. And that is this side so far. We come over here and we get to different factoring techniques. So this is our regular guess and check or product and sum, whichever one you feel more comfortable with. So what two numbers multiply to -20 and add to -1? If you need to write a list of numbers to multiply to 20, you can do that, but I hope you see 5 and 4 are the numbers that are really close. And I always like to just write 5 and 4, and then I take a step back. I know I need a -1, so that's why I'm going to make 5 negative and 4 plus. Divide. This is difference of perfect cubes. So what two numbers multiply to -9 and add to 0? It always has to be the same number, and it always has to be opposite signs. And that's why it's going to be -3 and 3. All right, so all the factoring is done, and now we try to find things that we want to divide. We don't have a lot here. We have y plus 3 and y plus 3, so we're able to divide that. And we have y minus 5 and 1 minus 5. And both of these are just going to stay the way they are. And we have 4 over 2, which is just going to give us 2. So remember, when you multiply fractions, you multiply across, and we are left with 2 times y plus 4 over y minus 3. And this is our final answers in terms of just finding the solution. One thing that is sometimes confusing is something called excluded values. Excluded values are numbers that make our denominator 0. So if you look at the original problem, you always want to focus on this and this, because this is our denominator, and we need to find out what number makes the bottom 0. So here we factored and we had y minus 5. So all I'm going to do is take the y minus 5 and set that equal to 0. Add the 5. So I'm going to say y is not allowed to equal 5, because if you take 5 and you plug it in here, 2 times 5 is 10, 10 minus 10 is 0, and that is undefined. And we're going to go ahead and continue to do the same thing over here, and I hope you see that that is where we got y minus 4 and y plus 4, except it got inverted. So that's what's strange about dividing rational functions. It's undefined here, but on our next step, it ended up being our numerator. Since the original problem is undefined at these points, we need to include these in our excluded values, even though they're in our numerator. Because right here, they were on the bottom, so we need to exclude them. So I'm just going to take both of these and set them equal to 0. However, we already took care of y minus 5, so we're going to do y plus 4 equal to 0. Subtract 4. Y cannot be -4. In the last step, you did the reciprocal of this, so now this also has to be excluded. And this gives us y plus 3 and y minus 3, and you go over there and do the same thing. And I hope you see y cannot equal negative 3, y cannot equal 3. And that's pretty much it. Thank you.